Your compressor is slowly killing itself, but I made a $30 fix that saved mine from becoming scrap. Instead of a surprise $400 or $800 bill, I'll show you how you can protect your compressor with a simple $30 device. But warning, doing this wrong can cause more problems. So how do you automate it safely? And what's the one crucial trick that you can use to keep your compressor from trying to kill itself when it tries to turn on? After my near disaster, I spent weeks coming up with the perfect solution. I'll show you my exact setup so you can use it too. Let's get into it. So I was building some new cabinets for my wife's office, and as I was nailing it together, it wasn't nailing. The staples were just going halfway in, and I was like, what the heck is going on with this thing? I thought maybe I left my compressor off, but I went over to check it, and the pressure was at like 70 psi instead of 0 or 90. It was definitely below the cutoff where it should turn itself back on automatically. So I tried turning it off and on, of course, but that didn't fix the issue. Nothing happened when I turned it on and off. I tried draining it the whole way down. I turned it off and I left it off for a little while. Then when I turned it back on, it ran and it loaded up the air and it worked a few times. So I was like, okay, maybe that was just like a weird fluke. But then after like 2 staples, it stopped working again. So I tried it a couple more times and I noticed that when it finished pumping the air, that it didn't do the normal like I know what that does now, but I didn't know at the time. Anyway, I figured the compressor was broken and I was gonna have to buy a new $800 compressor if I wanted the same one. While I was looking on YouTube, I thought, wait, maybe I should just see why is this thing broken? So I started looking up why compressors break. Eventually, I found one that matched some of the symptoms I was seeing, and I learned that the problem could have been with the check valve. It turns out that when it doesn't make the loud hissing sound, it's because the check valve isn't working. The way these compressors work is that the pressure sensor, that's where the power switch is on the front of this compressor, when it gets to full pressure, it releases the pressure that's in this hose between the pump and the tank. And this valve here, called the check valve, has a spring in it. When the pressure in the hose becomes low enough, the pressure inside the tank pushes the check valve back and no air is allowed to get out of the tank. The unloader valve is connected through this rubber hose on the back of the check valve. It's connected to the metal hose, which is connected to the pump through here. But when the check valve is closed, there's no connection between the tank and either of these hoses. So immediately after it closes, the pressure inside all 3 of these areas is the same. But when the unloader valve is opened and the pressure switch, there's a connection to the atmosphere through this tube back into the unloader valve itself. So that can relieve all the pressure inside this hose. So what was happening to me is instead of the valve getting closed, there was something in the way keeping it from closing. So actually the air was just slowly escaping until it got down to a lower pressure. So I followed the instructions in these videos. I disconnected this hose. I cleaned out the check valve with some pokey things to grab, and what I saw in there was little pieces of rust. I got rid of the rust, I hooked everything back together, and it was fixed. Woo! For 3 days. Then it broke again. After it broke again, I was wondering why. I thought back to when I was fixing it and noticed the little pieces of rust inside the check valve. I also remember that the hose that was between the pump and the valve was kind of rusty. So I thought, man, this hose is rusty. Maybe the rust that's inside this hose is just getting itself caught up in the valve. So I decided to look and buy a new hose. That wasn't easy to figure out exactly what hose it was. The instructions in these manuals aren't exactly easy to follow, but I lucked out, got the right hose. I replaced it, and of course, it fixed the issue like it did before. But I thought to myself, is this just a symptom of a bigger problem? Like, what's going on here? This shouldn't be rusting. So here's what I figured out. Inside my shop, I have PEX running all over the place for air lines that go all the way over here, and here, and here, and here, and up here too. The problem with this PEX is that it's kind of leaky. Air comes out of it slowly. I would notice when I'm working in my office on the other side of the wall that the compressor would run about every 90 minutes. That means it was losing enough air that it needed to, bring the pressure back up every 90 minutes. Every time it would run for about a minute, that means it was running several minutes a day when it didn't need to. The problem is it's very humid and wet in a compressor. Why does that happen? Your compressor pulls in ambient air holding whatever water's in it. The more humid the air, the more the water. As the air gets compressed, it heats up a lot. The water vapor stays a gas, so there's a lot more water inside the tank than would fit in normal air. But as the air sits in the tank, it cools down. the water vapor in the air precipitates and turns to liquid water, which falls to the bottom of the tank. This is why compressors will rust out over time if you don't drain the water out the bottom of them. What's interesting here is when the pressure is released after the cycle, it actually releases all the pressure outside this hose, but it's still enough water stuck in that hose for it to rust. So the problem that I try to fix here is just keep this thing from running so much. So I decided the best option here is that every time I come in the shop, I'll turn on the compressor, and when I leave, I'll turn it off. And then I won't have this problem anymore. No. Yeah, right. We need to automate. So I have to figure out what I can automate this with. I realized after thinking for a while that, obviously I only need to have this thing running when I'm in the shop. And there's something else in here that's always on when I need to use it that I already have to turn on and off manually. The lights. And I'm already using a Pico switch to control my lights. So you think, just plug this compressor into a smart switch and hook it up through some kind of automation system and everything will be great. But not so fast. Smart switches are only designed to handle resistive loads like a light bulb, and they can't handle that many amps. So I knew that wouldn't work. My compressor, California Air Tools 10020 AC, has a running current of 7.6 amps at 120 volts, which is around 900 watts or 1.2 horsepower. Also, the startup current will be approximately double that. I looked around for a different solution that could work. I found this heavy duty switch. It says that it can handle 15 amps, and the literature mentions things like sump pumps and refrigerators, which are very similar to compressors. So I figured it should work, so I tried it out and it worked fine. There's only one problem. There's a problem with controlling a compressor with an automated switch. When the compressor stops normally via the pressure switch in this, an unloader valve releases the trapped air pressure between the compressor pump and the check valve. That means when the motor restarts, it only has to overcome its own friction and not the built-up pressure inside the tank and inside the hose. If you cut the power while the compressor is running, but before it gets to the point where it reaches its pressure limit, the unloader valve never has a chance to release the pressure inside the hose. That means the hose stays pressurized. When you try to restart the compressor, the motor has to try to overcome its own friction and the pressure inside the hose. That's called head pressure. This can cause the motor to stall. It'll sound like a humming sound instead of the motor just starting like normal. It can also trip the circuit breaker or overload my smart switch. Luckily, this smart switch has overload protection, so it would actually protect the circuit, but it's not good for the switch. And it's definitely not good for the compressor. So of course I solved this problem the best way, with software. The maximum time that this compressor ever needs to run is about 90 seconds. As long as I'm not actively draining the lines, the compressor will reach full pressure and turn itself off. So I came up with this timer. When I press the off button on my light switch, it starts a timer. When the timer expires in 2 minutes, then it cuts the power to the compressor. If I turn on the lights while the timer's still... All right, compressor. If I turn on the lights while the timer's still running, I just cancel the timer. Let's take a look at how this works. This is my Home Assistant dashboard for my shop. You can see here the state of the lights and the compressor. This is off. I brought the switch from the wall and I'm gonna turn the switch on to show you what happens. So if we turn the switch on, you see there, the lights turned on and the compressor turned on. So you can also see that smart switch is showing how many amps the compressor is using. So you can see it's using about 11 amps. Now I'll take the switch and I'll press the off button. You can see the lights turned off, but the compressor did not turn off, but it started this timer. So the timer is 2 minutes. It will just count down for 2 minutes and then it will turn the compressor off. Okay, so you can see there the timer expired and the compressor turned off. So there's one other thing. So if I turn this back on, you'll see that it is on, and I turn it off, the timer starts again. I turn it back on and the timer is canceled. So if we didn't cancel the timer, then 2 minutes from now, the compressor would turn off even though the lights are on. So you would have to hit the on button on the switch again to turn on the compressor. Okay, so now we're gonna show the two automations and the timer that make this work. So if I go into the shop on automation, when you press the shop Pico, which is the switch that I was holding up, then that's the trigger, and then it turns on the shop lights. It turns on the compressor. and it cancels the timer. And this is the shop off automation. Just when you press the off button on the shop Pico, then we turn off the shop lights and we start the timer. So the way the timer works is that we have this timer integration, and the timer itself doesn't actually do anything except trigger an event. But if you look at the configuration for the timer, you can see that it has a duration of 2 minutes. For when the timer expires, we have a separate automation. So when the timer.finished event fires for the timer.compressor turn off timer, then we turn off the compressor, which is just a regular switch action. So I know a lot of you probably don't have Home Assistant already set up, and even if you do, you probably don't have a Z-Wave set up. So I will leave links in the description to some videos about how to set up Home Assistant and how to set up Z-Wave. So I've been using this solution for about 6 months. I haven't had any issues. The compressor always works when I need it to work. Sometimes I need to use it outside, like to fill up the tires, but then I just have to turn on the lights to the shop. So that's kind of annoying, but it's not a big deal. This solution works for me to protect my hose, but if you have a steel tank, you should definitely be draining your compressor, especially if you live somewhere humid. You can buy an automated system that goes into the bottom tank, or you can come up with a system on your own. But I looked into doing that, and it seems like just buying an automated system is a lot cheaper than all the components you would need to do it yourself. A link to the smart plug I used and the automations are in the description. If you like this project and you want to see more, please subscribe.